Hey mathlets! Alright, thanks for joining me again. Today's lesson is going to be on trigonometric functions and the unit circle. Pretty intimidating things, but we'll work through it. Okay, so first of all, we're going to have to understand what these are. Let's get right into it. First of all, the unit circle. Alright, so the unit circle is a circle with a radius of 1. That is a tool for visualizing trigonometry and trigonometric functions. So, this will make a lot more sense once we get into trigonometric functions. But basically, this circle is very useful for making angles and visualizing how sine and cosine and tangent are used and what they really mean. This is very useful for graphing and solving triangles, and it helps give meaning to what sine and cosine tangent actually are. So, now on to trigonometric functions. Alright, so trigonometric ratios done quick and without a calculator. So, here they want us to use the unit circle to find the exact value of each trigonometric ratio. So cosine 30, sine of 120, tangent of 225, cosine of pi over 3, tangent of pi over 3, and sine of 3 pi over 4. Now that looks like a lot, but with the unit circle, especially having it memorized, makes this super quick. So, all we really have to know for this little first part, cosine is going to be the number on the left, and sine is going to be the number on the right. I'm referring to that. So, cosine of 30, just go to 30 degrees, and then it's quite simple. As we can see, it is square root of 3 over 2. And then we have sine of 120. So we go up here and notice, oh, it's also square root of 3 over 2. And now we have tangent, which is not so straightforward. So, but it can be done pretty quickly and pretty simple. First, we need to understand what tangent is asking of us. So, as we should know, sine is equal to y, and cosine is equal to x. Now, tangent is equal to y over x. So you're going to need to do a little division here. So, tangent of 225. Let's go to 225. And we have negative square root of 2 over 2 over negative square root of 2 over 2. So now we're dividing fractions. But, as I'm sure you'll notice, anything divided by itself is equal to 1. So, it's pretty simple. After all, it's just 1. Alright, now moving on to the radians, or the pi's. We have cosine of pi over 3. So we can just look and notice it's right here. And we know the cosine, that should be 1/2. 1 over 2. And let's just do sine before we go into tangent with that. So we have the 3 pi over 4. 3 pi over, I always lose these, right here, 3 pi over 4. So that is going to be the square root of 2 over 2. So nothing that hard there. And now we have the tangent, which is pi over 3, same as cosine. So now we have to set this up. So the sign would go on top because it's the y. So square root of 3 over 2, and then 1 over 2. And what you'll probably notice is here is that they have the same bases. So just cross those out, and we are left with square root of 3 over 1. And then we have our exact value here. So then we have our square root of 3 over 1. And it's so much simpler this way. This is an easy way to solve it. Tangent, a little intimidating, but we got through it. All right, next question. All right, so now we're going to be constructing a sinusoidal equation and a graph. Skipping ahead here. All right, so first things first. A certain trigonometric function has a maximum point at pi over 4 and 3, and a minimum point of pi over 2 and -1. Write the formula of the function, so we have to find the formula here. So these are some useful notes. I'll come into play real soon. But first things first, what we want to do is we want to make a graph. All right, so make yourself a graph, and as you notice, we're not going below 0, so we're not really going to need the left side of it. All right, so we're going to want to label our points. So right here, we're going to have 3, and right here, we're going to have 1, and then we're going to want to have our pi over 4. And then our pi over 2. And now we're going to just add our little dots. So now that we've got that, we're going to want to connect them. And since we know that this is sinusoidal, it's going to follow the little wavy pattern. That's all right. It doesn't have to be perfect. Okay, so now that we've got that graphed, we'll probably just go ahead and make some predictions. All right. So first of all, since we have a little maximum, we're starting here. We're going to want to use cosine because cosine, the little graph of cosine, that starts at the maximum. It's just going to make things easier for us. So first of all, we're going to want to find the amplitude, which is what's going to start off our equation. So, RA is equal to our maximum, which is going to be 3, and then a minus -1 over 2. And that's going to be 4 divided by 2, so then 2. So we've already got that little first part out of the way. So then we're going to want to start our equation. So y is equal to 2. Then we've already chosen that we're going to do cosine because it'll be easier to line it up later. Cosine. And now we're going to want to find b. So now we're going to be solving for p, or r period, which is about represents the full rotation of like from maximum to maximum or minimum to minimum. So we're going to want to find that out so we can include that in our equation. So what we're going to want to do is we're going to want to get the length of half of 1, which we already have out here. So let's make that a little bigger. We're going to want to subtract these two values, which is pretty simple. We're still just going to have we're just going to be left with pi over 2. So then we use our little equation here. So then, yeah, that doesn't really matter. And then that's going to be equal to 2 pi over b, and we're going to want to isolate b there. So if we cross multiply, we'll be left with 2 pi, 4 pi equals pi b. And then we can just divide by pi to get rid of it. And then we'll just left with b equals 4. Awesome. So now we have a little bit more of our equation. And then we're going to want x. And now we need to find h. So now we're going to find h, or the horizontal shift. So now we see it's shifted pi over 4 away from 0. So then we're just going to be subtracting pi over 4, which is real handy. So now we're almost done. Oh, so I forgot to close that. Or the creator of this problem forgot to. Regardless, alright, so now we need to find k. And k represents the vertical shift. So pretty similar to h. We have a little equation for that there. So we have k is equal to our max of 3 plus negative 1 over 2. So that's just 2 over 2. So that's going to be 1. And now we have plus 1. So now we have made a function from such a little amount of information. Great job. Hey guys, thanks so much for watching. Be sure to like and subscribe. I'll be sure to make a new video every time I fail math during a global pandemic. So thank you, Malizer, and thank you all for watching. Goodbye.